Okay, we're on page 27 here, and we're going to be practicing solving for missing angles in right triangles. So when we do that, we're using what we call an inverse sine, and it looks like it's written like this: inverse of sine, or an inverse of cosine, or the inverse function of tangent. And an inverse is basically kind of like undoing an operation. So what that means is, for example, remember my favorite 45-degree right triangle. If we have a slope ratio, a slope triangle, and we have 45 degrees, we can make the sides any length, and they'll, of course, be the same, right? So 10, this side's 10, 10 divided by 10 is 1. No matter what number I make these sides, if this angle here is 45 degrees, these two sides here would be the same. So we know that tangent of 45, the ratio between those two sides is 1. So tan 45 equals 1. Now, if you're on the main calculator, you won't see these special buttons here that have inverse ratios, but you're going to click on this function, and we're going to click for it, go down one line. So instead of given the angle and getting the ratio from that, you're doing the opposite. I'm giving you the ratio, which is 1, or whatever my numbers would be divided, and then from that, you're getting 45 degrees. So it's just kind of the opposite operation here. So let's try a few together. So we use these inverse sine, cosine, tangent values when we are solving for missing angles. And that's what we're doing here, solving for missing angles. So in our first problem, we've got from this angle, our question mark angle here, we'll call it theta, we've got this side, which is an adjacent leg, and we've got this side here, which is a hypotenuse. So reminder that the sides that form your right angle are the legs. And because this leg is blank, we're not using it. We're only using the leg that's next to the angle we're solving for and the hypotenuse in this triangle. So we can say that missing angle question mark, I'm going to use theta instead of a question mark. Remember, theta is our variable for angles. I'm just going to say theta is equal to, now this is A and H. You may still want to write this on your paper, sine, so, ka, toa. Now for this problem here, we have an A and H, that's a cosine ratio. So I can say it's the inverse cosine of these two sides divided by each other. Remember, it's adjacent over hypotenuse. So 35 over 48. So now that inverse ratio is going to tell us our angle instead of giving us a ratio, which is what we were doing previously. So then I can say it is approximately inverse cosine of 35 divided by 48. So I'm going to just click on this inverse cosine of 35 divided by 38. And it's going to be 22 point, we'll say 919. That rounds to 920. 22.920. And that's it. All right, let's look at, I want to do a couple with you. So let's look at the next one here. We have, from this angle, we're solving for a question mark. Remember, these are the legs. Okay, one leg is blank, but the leg opposite is this side here, and this is the hypotenuse. Remember, hypotenuse is always across from the right angle. So we have an opposite and hypotenuse. So then I say, okay, is it sine, cosine, tangent, O and H? That is a sine ratio. So my angle measure here, theta, that I'm looking for, my missing angle is equal to an inverse sine ratio of opposite over hypotenuse. And then we just input that into the calculator to get our missing angle. So inverse sine of 28 over 44. And that's going to be 39.521. 39.521. degrees. And I forgot to put degrees on the other one here. Okay, and then I want to do one other problem with you, but I want to do a problem that has an inverse tan. Let me find one. There's one at the bottom here. So here, this problem, we've got from this angle we're solving for, our reference angle, these two sides are legs. So we've got an opposite leg and we've got an adjacent leg. So remember that would be TOA for tangent, opposite and adjacent. So we are going to use an inverse tangent ratio. So our angle that we're solving for, theta, is equal to the inverse tan of my opposite over adjacent, 11 over 12. Inverse tan, 11 over 12. Oops, not regular tan, inverse tan. At 42.510, 510 degrees.